Hello. In this video, we'll be discussing about the basics of project management. So before we start, we just want to discuss about the basic definitions of the project and project management. So what do you mean by a project? A project is a temporary endeavor involving a connected sequence of activities and a range of resources, which is designed to achieve a specific and unique outcome and which operates within time, cost, and quality constraints, and which is often used to introduce change. So, project is nothing but it's a temporary activity using which a certain objective of an organization that can be achieved within the constraints of time, cost, and quality. Now, what are the main characteristics of a project? A unique one-time operational activity or an effort. It requires completion of large number of interrelated activities. So, project normally consisting of different activities, and all these activities are connected one another. Established to achieve specific objectives of an organization. Resources such as time and or money are limited or restricted. Typically has its own management structure. So the organization structure for a specific project may be unique, and it may not be same as the other type of projects. So from project to project the structure may change. And normally the project will be handled by a leader. We call as the project manager or the project leader. Now let us look at some of the examples of the projects. Constructing a house, factories, shopping malls, athletic stadiums or arenas. Developing medical equipment, military weapon system, aircraft, new ships. Developing new methods of maintenance and service. Launching satellite systems. Constructing oil pipelines. Developing and implementing new computer systems. Planning concert, football games or basketball tournaments. And in the universities, undergraduate or the postgraduate level, the students' projects, the research projects. Introducing new products into market. So there are several examples of the projects that already have discussed. Now, what is project management? The application of collection of tools and techniques to direct the use of diverse resources towards the accomplishment of a unique, complex, one-time task within time, cost, and quality constraints. In other words, it is a management of resources, management of available resources in order to achieve a specific goal of an organization within certain limitations or constraints, which are time, cost, and quality. Its origin lie in World War II, when the military authorities used the techniques of operational research to plan the optimum use of resources. One of these techniques was the use of networks to represent the systems of related activities, or one way of solving this type of project management by the help of networks. So what is basically the project management process? The first step in all the project management is the project planning. Then project scheduling, project control. Then we have to frame or design a project team, and which made up of individuals from various areas and departments within a company, from different disciplines, different specializations, etc. Then we have to form an organization structure Normally, they follow a matrix organization where you will find combinations of departments, a team structure with members from functional areas depending upon their skills required. And of course, the whole thing has to be led by a project manager, most important member of the project team. And there must be something called scope statement, a document that provides an understanding, justification, and expected result of a project. Statement of work, a written description of objectives of a project. Organization's breakdown structure, how the structure is being, divided into small sections, small, units or small sub-organizations, substructure and so on. A chart that shows which organization units are responsible for work items. Responsibility assignment matrix shows who is responsible for work in a project. So these are the different project management processes. Now the work breakdown structure means method of breaking down a project into individual elements, components, subcomponents, activities and tasks in an hierarchical or sequential structure which can be scheduled and cost. It defines a task that can be completed independently of other tasks, facilitating resource allocation, assignment of responsibilities, and measurement and control of the project. And this work-done structure can be considered as foundation of project planning. It's developed before the identification of dependencies and estimation of activity durations. Can be used to identify the task in the CPM and PERT. These are the two techniques which we are going to discuss in this particular session. So here we can see the breakdown structure of a computer order processing system project. So the project title is Computerized Order Processing System, and which basically consisting of three main sections, which is hardware section, software or the system, then the personnel, the staff. So in the hardware we have in the following sections here: installation, area preparation, technical engineer, technician or engineer, then wiring, connections, etc. So likewise here also we can. So here actually is a way of breaking down the organization into small units, and there is a hierarchy or a sequence is there, who should be responsible for what, and who are the subordinates and who are the supervisors. So this type of structure normally called as a breakdown, the work breakdown structure, and it's very common in the case of project management. Now the important steps in project management is the project planning. So where we'll be looking at the availability of the resources and also its limits, the budget, due date, the penalties, early completion, incentives, etc. We also will be looking at the activity information, identify all required activities, estimate the resource required time to complete each activity, immediate predecessor or the prerequisite, normally we call as a prerequisite or the immediate predecessor to each activity needed to create interrelationship. So we'll see these details in the following sessions. Now mainly there are two types of techniques that we follow. Number one is called the critical path method, which is also called as CPM. The other technique is called program evaluation and review technique. It's also called PERT. And the project network, a network that shows the different activities and the precedence. So this network will help us to identify the duration of the project, the critical activities, non-critical activities, the timing, the dummy activities, etc., etc. So these networks are of two types. One is called AOA, which is called the activity on arrow, and the other type is called AON, which is called activity on node. So as the name says, it is an activity on arrow, which means that this is called a node and this is also another node, and this is an activity. So the activity happening on the on the arrow. So that's why this particular type of graph is called AOA graph. And suppose if the activity is taking place on the node, such type of network we call as the AON. So here we have a start activity, and here node 1. The node 1 is indicating a particular activity. So the node itself is acting as an activity, and this arrow is just to show the direction only. So these type of networks are called activity on node. So let us look at one example here. We can see there are different activities here with the activity number and the corresponding completion time here. Then we can draw a network graph only if we know the interrelationship between the different type of activities. So the activity number 1 must be finished before 3, which means that for 1, 3 is a predecessor, and for 2, 4 is a predecessor. Sorry, in this case 1 must be finished before 3, means in order to start 3 we must finish 1, or in order to start 4 the activity number 2 has to be done. So which means that these are the predecessors and these are the activity. So if you want to start the particular activity 6, in this case 4 must be ready, 7 based on 5 and 6, 8 based on 7, 11 based on 9 and 10. So accordingly we can draw a network graphs like this, and the bracket we can see the duration here. So this particular activity is like an activity on node AON, because the node is used to represent the activity. So next thing is how you do the CPM calculations. So there are some the terminologies which are called path. It's a connected sequence of activities leading from starting event to the ending event. That is known as the path. So start from the starting node until the ending node. The path followed by the network, that is called that is indicated by the term called path. Now the critical path is the longest path or the longest time determine the project duration. So the critical path is equal to the project duration. Critical activities, these are the activities that makes the critical path. Now there are two types of paths we follow: starting node to the ending node, that is normally called as forward path or forward pass. So here the different time estimates. Number 1 is called the earliest start time. Earliest time that an activity that can start. Then we have something called the earliest finish. Again, the earliest time an activity that can finish. So early start, early finish. Then early start plus T will give you early finish, because T is the duration of that particular activity. So early start plus duration of activity, that will give you early finish. Now if you look at the backward pass, which means we are moving from the end node to the starting node. In such cases, we follow different time estimates which are called latest start time and latest finish time. So the latest start is indicated by LS, which you can calculate. LS is equal to LF the finish minus T. Again, T is the duration of the activity. So latest finish means the latest finish or the latest time an activity that can be completed without delaying the critical path. So this activity indicates how much amount of delay that can be achieved without affecting a critical activity. So in CPM analysis, the first task is to draw the CPM network based on AOA or AON. Then analyze the path to the network. You have to follow the path. Then determine the float for each activity. The float is nothing but it is the time difference between early start, early finish, or late start and the late finish. So we'll discuss that in the coming slide. Compute the activities float. The float is equal to LS minus ES, which is latest start minus the earliest start, or latest finish minus earliest finish. Float indicates maximum amount of time that the activity can be delayed in its completion before it becomes a critical activity. Or the float symbol means this is a time where a particular activity that can be delayed without affecting the total project completion time. Then the next job is critical path. The critical path is a path consisting of the activities with zero slack or zero float. So identify the activities that has got zero float or zero delay. Such activities are called critical activities, and the path that is formed by these critical activities called the critical path. So the length of the critical path is equal to the total project duration, and it is called critical because if you delay any of this critical activity, the whole project will be delayed. Now let us look at an example here. So we have a network graph is already given, and there are A to H activities. The activity name or the name of the activity and the duration is already given. So we have A, B, C. These are the starting activities. Then F, G, D, E, I, J and H. So these are the total activities. Totally we have So totally we have 8 nodes available here. So the first job is we just draw the CPM network based on the predecessor or based on the interdependency of the other events. The next job is we have to find the early start and early finish. As we know that A, B, C are the initial activities, their starting time is 0 because these are the first activity, therefore the starting time is 0. So 0 plus 6 will give you 6, 0 plus 8 will give you 8, 0 plus 5 will give you 5. So we got now the early start and early finish. The same thing that can also be continued. For example, in this case, this particular activity A will be finished at 6. So the starting point of this is supposed to be 6 here. So this is 6. 6 plus 15, that will make you 21. So this is supposed to be 6 and 21. Okay, now same way this is 6 and 23. This activity is completed at 8, so 8 and plus 13, that will make you 21. This activity is already finished at 5, so 5 plus 9, 14. Then the same procedure will be continued for the remaining branches or the activities. So we can find 23 and 29, 21 and 33, 21 and 30. So if you see, we have to find out the longest path that will give you the project duration. So we can see that in this particular case, the longest path is 33. So which means that the project's early finish time is 33. So this is we call as the forward path, and we found now for each activity 2 time estimates, the early start and early finish. Now we'll go for a reverse or backward. So in the case of backward flow, so we start from the latest time, because the latest time is 33. So we have to start all the activity which is for the latest time. So we are going to start with 33, 33 and 33 because the earliest finish is 33. So the earliest finish is, as per the earlier case, we have the EF, earliest finish is 33. So we'll start from 33. So 33 minus 9 will give you 24. 33 minus 6 will give you 27. 33 minus 12 will give you 21. Then we'll move to the next. So out of this, when we go back, always we have to take the minimum number. So out of these 3, we have 24 here. So this is 24, so 24 will be here, and this is 27, 27 will be here. This is 21, so we'll have 21 here. Then we'll go for the next step and so on. So what we can see that we'll have now 4 time estimate. The first one is ES and EF. This is LS and LF. So early start, early finish, latest start, latest finish. Now the next job is we have to calculate float. The float indicates the difference between the latest start with early start, or latest finish with early finish. So in this example, we can find that 33 minus 30 will give you 3, or 24 minus 21 will give you 3. So we can find vertical, take the difference in along the vertical line, which means 24 minus 21, 33 minus 30, 24 minus 21, 27 minus 23, 21 minus 21, 21 minus 14, and so on. So that part is normally called as float. So the float, as we said before, float is the time delay or that particular project that can be delayed without affecting the total project duration. But it's also interesting to note that some of the activities which have 0 float here. So we have an activity B which has 0 float. We have an activity D which is also having 0 float. We have an activity J also having 0 float. So which means that these activity, no way that can be delayed. And since these are the critical activities, we can call this particular path is called the critical path. So by connecting the nodes B, G and J, we'll get a path. That path is called the critical path. So this shows that these activities are critical. Any delay in these activities, that is going to make the whole project will be delayed by some amount. And if you look at the other activities, these activities are non-critical, which means that these particular activity that can be delayed by an amount called float without affecting the total project duration time. So in this particular network, we can see that there is only one critical path, and that critical path is formed by B, D and J. Next point is we are talking about project cost. As we have said before, the project cost is one of the critical element of a project management. So the project managers may have the option or the requirement to crash the project, or the crashing means we have to accelerate the completion of the project, or we have to push ourselves to complete the project before time. This particular step normally in project management is called crashing the project. So crashing the project means we have to finish the project well in advance. So definitely we have to pay some extra amount. This is accomplished by reducing the length of the critical path. So we have to focus on the critical path. If you touch the critical path, so that the whole project duration that can be affected, can be changed. The length of the critical path is reduced by reducing the duration of activities on the critical path. If each activity required expenditure of an amount of money to reduce its duration by 1 unit of time, then the project manager selects the least cost critical activity. So when a project manager try to crash the project, always he should look for the critical activity that will give the least cost, so that the additional amount the project manager is supposed to pay will be the minimum. And sometimes when you crash one particular activity, the critical path itself may change, or we may have multiple critical paths, and that makes the network more complex. So if there are multiple or more than one critical path, then we have to control both the critical path in order to crash the project. So if we just focus, for example, if we have two critical paths, and if we just focus on one particular project, the critical path, the entire project will not be crashed, just because of the fact that there are two critical paths there. So if there's a two critical path, we should make change in both critical path simultaneously. Now project crashing, as we said, it is reducing the project time by expending additional resources. Additional resources means we have to do the job, do the job well in advance, so we have to allocate more people or more resources in terms of money, in terms of machine, equipment, man, etc. So human resources is also required for crashing the project. So we are ready to pay some extra amount so that the project that can be completed beforehand. Now the crash time, the amount of time and activity that can be reduced, that is normally called as the crash time. Crash cost means what is the additional amount of cost that we have to pay in order to crash the project. The main goal is to reduce the project duration at minimum cost. So there are two important objectives there for project crashing. We have to reduce the project duration, or we have to speed up the process. At the same time, it should be at a minimum cost. So now let us look at the crashing activity and how do you calculate the crash slope. So here you can see that the y-axis is the activity cost and here is the time. And the green text indicate this is the normal activity, and the red one indicate the crashing activity. So we can see that this normal activity is it's a normal activity that is costing this much, and if I am going to crash this particular activity to minimum, or if I am going to reduce the time of this particular activity, definitely have to pay extra money. Now, this particular line which connect between the crash activity to the normal activity is called the crash line, and we're supposed to calculate the slope of it. And the slope normally calculated by, we have to find out the crash cost. So this is the crash cost. So we have to find the slope, which is y by x. So crash cost is this. So crash cost minus normal cost will give you y, divided by normal time minus the crash time. So crash slope is calculated by the form. It is nothing but slope. Slope is equal to y by x. So y is crash cost minus normal cost divided by normal time minus crash time. This will give you crash slope, and crash slope indicates the crash cost per unit time. For example, it is per hour, crash cost per hour, or crash cost per day, etc. So let us look at an example here. We have a particular project which consisting of 7 different activities, and already AON network is given. So these are the different activities, and normal time is given here, and this is the normal cost. Crash time is given, and the crash cost is also given here. And the crash limit is there. It's a restriction or the constraint, the crash time here. So let us look at one by one detail. So the activities are 7 activities. The normal time is already given. This is the normal cost. So if you follow the normal time, then definitely the first activity will take 12, second activity will be 8, 4, and so on. And this is the corresponding crash time. Now, if it is a normal activity, then the activity 1 will take 12 days, for example, and which will cost you 3,000. The same activity we can reduce to 7. So instead of 12, we can reduce that time to 7, but we have to pay additional amount of 5,000. The particular project will take 12, which is costing 3,000. The same amount, same activity that can be completed in 7 by paying 5,000, which means an additional cost of 2,000. So please, try to understand here. 3,000 is the normal cost, whereas 5,000 is the crash cost, which means that if you want to do the job, the activity 1, normal expense is 3,000, but if you want to do in 7 days, we have to pay additionally 2,000, which means that the total of 5,000 has to be paid. So here we can calculate the slope, the crash slope, by 5,000 minus 3,000, which is 2,000, divided by 5. So we'll get 400. So this is the crash cost, 5,000, minus normal cost, 3,000, divided by the normal time is 12, 12 minus 7, which is 5. So same way, 3,500 minus 2,000, which is 1,500, and the corresponding time, crash time, is 3, so which is 500. 7,000 minus 4,000, which is 3,000. 3,000 divided by 1 will give you 3,000. So this indicates the slope, or this is nothing but the crash cost per unit time. So what you can see that if you are following the normal cost, our cost will be something like 75,000. Whereas if you go for the crash, the same project that can be completed at the cost of 110,700. But again, we have to keep in mind that the crashing should be applied to only the critical activities. So our job is to find the critical activities first. So based on this activity, we found that the total project duration is 36. Okay, now if you want this particular project that is to be completed in 31 days, then additionally we have to pay an amount of 2,000 here. So we can save 5 days at the cost of 2000 extra. So that is the difference between the normal project and the project crashing. Now we look at the benefits of having CPM output. It is useful at many stages of project management. Mathematically, it is very simple. Give a critical path and slack or float time. Provide project documentation. Useful in monitoring cost. And also CPM PERT can answer the following questions. How long will the entire project will take to be completed? What are the kind of risks involved? Which are the critical activities in the project, and what could be delay the entire project if they were not completed on time? Is the project on schedule, behind the schedule, or ahead of schedule? If the project has to be finished earlier than planned, what is the best way to do this at the least cost? Thank you for listening.